Hello, so today we're going to look at mixtures and separation techniques. So we're going to focus just on a couple of techniques, specifically filtration and evaporation. Okay, so there's a couple of new words that you're going to want to pay attention to. The ones that we're going to use, will be mixture, heterogeneous, homogenous, and then pure substance to start with. Later on in class, we will talk about purification, separation, filtration, and evaporation, etc. Okay, so a couple of things on this particular slide here is we've got our chart of matter. So if you start with matter, you need to look at, is it all the same substance or not? So that's what they mean by variable composition here. Okay, so variable composition. If it's all the same substance, so it does not have a variable composition, it means it's all identical, it is a pure substance. And we have two types of pure substances that we actually talked about last class. And those are elements, where you have all the atoms of one type, or all the atoms in the element are exactly the same, or a compound, where you have atoms of different elements that are bonded together. Okay? If you have multiple particles that are not attached together, so they're separate, but they're different, then you have what's called a mixture, and that's what we're going to talk about today. And so there's two different types of mixtures. Ones like the solutions that we've seen that are homogeneous, where they look like a pure substance, but they're not, and mixtures where you can see the different parts, or they look cloudy or things like that. Okay, so let's take a look at some examples. In this picture here, imagine that the candy are each different particles. First question you need to ask yourself, are they all the same? Do all of the pieces of candy look the same? If they do, then it's a pure substance. If they don't, it is a mixture. So this one here is a mixture because we've got yellow pieces, we've got rainbow pieces, we've got sticks, we've got what look like toothbrushes, lots of things like that. Okay? So just a reminder, this is from last class, so you don't need to write this part down because you have the notes already. A pure substance only contains one type of material. And actually, let me just go back. You do need to write the title, Mixtures and Separations. You can keep doing this well, you probably should start a new page, actually, because I'll give you an activity from atoms, elements, and compounds to do on the bottom half of your page. Okay, some of the things that we're looking at is how many different pieces are there and how could we separate them? In terms of the candy, we could probably just separate it by hand. So, coming back to pure substances, pure substance has only one type of material. So, this is something like pure gold or sugar, right? So, it only has gold or it only has sugar. Again, you don't need to write this part down about pure substance because you already have that information. A mixture, and you do need to write this part down, a mixture is a group of many different substances that can be separated. Okay, so the biggest difference is a mixture is a physical separation. So there's no changes to the substance when we take the candy out and you pick out only the teeth to eat, or you only take the rainbow candy. Okay, the rest of the candies all stay the same as they were. Okay, so we do have two types of mixtures. The first one is called a heterogeneous mixture. And this is where we can see the different parts of the mixture. So for example, that bag of candy, we can see the different parts. We can also easily pick things off or pick it out by hand. Okay, they're large pieces. Or for example, pizza. Sometimes when I order pizza, I forget to tell them I don't like olives. And so I end up with olives on my pizza, and then I have to pick them off. Okay, but I can do that because I can see the olives and I can see the pieces and I can remove it. Okay, so heterogeneous mixtures, you can see the different substances. This would also be like if you had a beaker with sand and water when you're at the, or even if you had a bucket with sand and water at the beach. Okay, or maybe in the water you've also got some seaweed, or you've got, let's see, what's another example. If you've ever made a vinaigrette, sometimes there's like oil and vinegar, but then they don't mix together and you have to shake it up to try and get them to mix. And they sit one on top of the other. That's a mixture. And those are all heterogeneous mixtures. The other ones are the ones that we've already talked about. We're just going to give a new name to it. Okay, so we're just going to add the term homogeneous mixture. A homogeneous or homogeneous mixture is one where it looks like a pure substance, but actually there's more than one substance, and they can be separated using techniques like evaporation or distillation. Okay. Couple of examples of homogeneous mixtures. This includes juices where you mix like the powder in and you stir it with water, Coca-Cola or soft drinks, so Sprite, that, what is it, plus water or whatever that drink is called. Okay. All of those sorts of things. Now, the trick with homogeneous mixtures is that usually they're going to be transparent so we can kind of see through them. Maybe not fully because of the color, but they're not going to be cloudy. If something is cloudy, like milk, it's actually a heterogeneous mixture. Okay? That one's a little bit of a trickier substance, though, milk. So, next class, basically where we're going to start with is we're going to start looking at how can we separate mixtures. So we'll begin with looking at homogeneous and heterogeneous mixtures because that's what's going to tell us how we should separate the mixture. All right. Remember to take your notes. Remember to add the date to your page and put this in your table of contents as well. Bye.